Hello everyone, welcome to this Java Intermediate course by Life Changes Academy. So far we have learned classes and object as well as encapsulation as well as inheritance, right? So today we are learning two powerful OOP concepts. One is a polymorphism and another one is a abstraction. These concepts help us write a cleaner, reusable as well as the flexible code. Okay, so without any delay we start our session. Okay, so first of all we are going to learn what is polymorphism. Okay, so polymorphism has two types. Okay, one is the compile time polymorphism and another one is the runtime polymorphism. In this slide we are going to see compile time polymorphism. First of all, you know what is polymorphism. So poly means many, morphism means forms. Okay, so this combine to form polymorphism. So one object or else one method behave in different ways. For example, you think that driver, okay, same driver can drive car, bike, bus and so on, right? So the person is same but the behavior changes depends on what vehicle he is driving. So this concept is the polymorphism. So another one example is I have a remote, right? A remote is one thing. Okay, remote is a one thing, but for a TV it changes the channels. For a fan it changes the speed. For an AC it changes the temperature. Same button but different behavior. This is exactly what a polymorphism means. Okay, so now we are going to see compile the two types of polymorphism. One is the compile time polymorphism. Okay, what is compile time polymorphism? This happens through method overloading. Okay, the compile time polymorphism is happens through the method overloading. So what is method overloading? That means same method name but different parameters. Okay, same method name but different parameters. So here Java decides which method to call while the compiling the program. Okay, so I will explain the compile time polymorphism in a practical way so that you guys are familiar in this concept. Okay. Okay. I will switch over to my code editor. Here I will erase this. Okay. Okay. In this code, I write some class before that. Class calculator. Okay. Have you guys known about calculator, right? Yes. Calculator performs the mathematical operations. This one is a compile time polymorphism. Compile time polymorphism. So polymorphism, poly means what? Many. And then morphism means forms. Okay, you note it like a hint. Okay, so that only after that when you forgot something means you will recall this one. Okay, so I write the class calculator. Okay, and then int add of int a comma int b. These are the parameters. Okay, the parameter value int a int b. Okay, and it will return the a plus b. Okay, the arithmetic operator. Okay, so and another one method is int add of int a comma int b comma int c. Okay, int c. Here also I will return a plus b plus c. Okay, a plus b plus c. Semicolon is necessary. I already said. Okay, a plus b plus c. Now I want the calculator to perform the addition of addition. Okay. Okay. Now I'm here. I will create a new calculator. That means I create a new object. Okay. Here I want to print sysout calc dot add of. I will give the values int a 10 comma 20. Okay, and then another one is calc dot add of 10 comma 20 comma 30. Okay, so now I run this code. Wait, I will first run this code and I will explain this one. Okay, when I run this code, what happened means it will give the output as 30 and 60. See, Java sees first Java sees two parameters. Okay, first Java sees 10 and 20. Okay, two parameter. Immediately it calls the first method. Okay, it calls the this method add method. Okay, immediately it calls the first method. Afterwards, it will see the three parameters. Immediately it calls the second method. Okay, now the Java takes the decision during the time of compilation, right? Therefore, it is called as compile time polymorphism. Okay, whenever the code gets compiled, that time only it decides the method. So, Java says it has two parameters. Okay, it will take the first method. Okay, it has three parameters. Okay, it will take the second method. Likewise, it will be decides the methods. Okay, this will called as compile time polymorphism. Okay, so next we are going to see another type, the important type of polymorphism here. That one is, so you have to do this task. Okay, try to overloaded add methods, one for two list and another for three. This only I do. You will do another task like this. Okay, so that only you will understand this concept completely. Okay, so another method is method overriding. This one is a runtime polymorphism. First we have seen is a compile time polymorphism. This one is a runtime polymorphism. This uses the method overriding. Here child class changes the behavior of the parent class method. Okay, real time example one is every animal makes sound, right? Every animal makes sounds, but the sounds are different, right? Dog is barking, and then another animal is making different kinds of sound. Okay, action is same, but the behavior changes here, right? This kind of polymorphism is the runtime polymorphism. Okay, I will show a simple code. Okay, so that only you will get practice in this method overriding. Also, you have to done this mini task. Okay, you have to draw is the method in a circle subclass of a shape. Okay, you have to draw a circle in the subclass. Means what is the child class? Nothing. This is child class. Child class is a shape. Okay, I will make another one code example so that you will familiar in this runtime polymorphism. Okay. Okay, I'll switch over to this my code. Okay, this is a runtime polymorphism. Runtime polymorphism. Okay, okay. This is the overriding concept. Okay, this will be the overriding. Overriding. Okay. First of all, you have to go. You have to create a class. Okay, class animal. Okay. In that, I have one method. I already say this example, but okay, no problem. I will explain another time also. Animal makes sound, okay, and then I will hold this, okay. Public class condition, okay. Inside that, okay. First we will write the another one class dog, okay. This one is void sound, void color. This is out is dog is in black color. we will overriding this concept. That means we will override the sound inside this dog. That means it's like the inheritance concept, but somewhat different. If I make mistake, Java wants me immediately. Okay, wait. I will run this code. Okay, we will creating a new object. That means dog d1 is equal to new dog. Okay, here d1 dot sound off. Okay, sound off, d1 dot sound off, and then d1 dot color off. Okay, now you see I will call these two methods, right? I will once again. I will call this two method. One is a sound method, color method. But the sound method alone shows the error. See here. But in the color method doesn't show any error. Why? Because means we are not using, we are not extending this one, right? We are not extends. I'm not extending the parent class, okay? When I am extending this class, this error will be gone, okay? Okay, when I am extending this, the error will be gone. When I am run this, animal makes sounds as well as dog is in the black color. This is how the runtime polymorphism. Whenever the code runs only, it shows it will be decide what, whenever the code runs, whenever this line runs only means it will call the sound method. Whenever this one is run, this will call this method, okay? This one is overriding method. Okay, at override is not mandatory, but something sometimes it shows an error. Okay, so child class changes the behavior of a parent class method. Okay, this is the runtime polymorphism. Okay, so another one concept is run. It is also runtime polymorphism. So decides which method to call at runtime based on the actual object. Okay, so the previous example, the example I will code no that one example also this. So first parent child object calling the method JVM invokes child. Okay, the child method. Okay, create animal parent. This task only I will done. You have to do this task. Okay, override draw in a circle subclass of a shape. Draw is a parent class, subclass is a shape. Okay, you can make that one. Okay, so next one is a important concept, that is introduction to abstraction. Okay, introduction to abstraction. So I have another one. Okay, that is no. Okay, abstraction means Java provides abstraction using abstract classes. Abstract classes means that hides the implementation details and exposes only what's necessary to the user. Okay, so abstract classes cannot create the object. So some example, vehicle is just a blueprint. Okay, we never see a vehicle called simply vehicle. We can see car, bike, bus, truck. Therefore vehicle becomes abstract. Okay, so abstract, a simple example is when you are going to the or else when you are withdraw money from ATM. Okay, so do you know how cash count happens, or else do you know how bank server communicates, or else how transaction get verified? No, you don't know that details and all. You only press withdraw, enter pin, take money. That's all. That's your duty. Okay, and then you don't know the back end. Okay, backside process. Okay, so this concept is abstraction. Like when you make a call means you will just click their person contact number. Okay, it will make a call, but you do not know whether the signal is routing or else the network towers, communication protocols, everything hidden. So what's necessary to you will be only displayed in this abstraction concept. Okay, so this is the overview of abstraction. It hide the complexity, show what functionality. So It's a two form, abstract classes and the interfaces. So we will be deeply see this concept. Okay, so now we are going to see abstract class. Okay, abstract class is a blueprint. That means it's like a class. Okay, class is a blueprint that cannot be instantiated. That cannot be instantiated. That means Java provides abstraction using abstract classes. Okay, abstract classes do not create an object. Okay, it doesn't create an object. It just uses an abstract keyword. While creating a class, you just create an abstract class. Okay. Okay. So abstract keyword is necessary for creating an abstract class. Okay. So don't forget that one. Okay. Vehicle knows every some example also I will give, and we will see that in next. Okay, so abstract method or like contract. Parents say you must provide this method. Child say okay, I will implement like that. Like that only it will be going. Okay, so this is the abstract class. Abstract class is nothing but the syntax is abstract class. Okay, before the class you should use abstract keyword. Okay, so create an abstract class vehicle with the concrete method stop off. Okay, you just create a abstract class vehicle and then abstract void method stop off inside that system.out.println vehicle stop. Just your simple program. Okay, so this task is very simple. You can do it by yourself. Okay, next one is a abstract methods. This one is just you have abstract declaration. You have to declare the abstract classes and you have to create the implementation. Okay, what does this means? Abstract methods means it contains only the declaration, no implementation. That means you know that vehicle knows every vehicle must start, but how cars start differently, bikes start differently, vehicle does not know. So child class must implement. Okay, so this is the major concept in the abstract method. Okay, so another one important concept is this abstract declaration only. So parent declares abstract start off. Okay, first we have to declare the abstract classes and then you have to implement. Okay, so this is just an go through session. Okay, so next we are going to use the abstraction in the real world. So in the real world, how abstraction is used? ATM machine, you already said that ATM machine, and then vehicle driving, and then payment system. So in the payment system, payment is common, right? So you guys know what kind of payment, right? What is it? Is an payment through GPay or else net banking or else it's like a wallet. So that's your wish. Okay, scan money or QR, that's your wish. Okay, in that car driving system only you will just know the start engine, accelerate, brake. Your combustion process is hidden. In the ATM alone you have to withdraw or else you have to check balance. The internal logic will not be shown. Okay, this is the abstraction derivative. Here the pick one example, map tools abstract operations to Java methods. Just you have to take one example in this and you have to perform the abstract operations. Okay, so this is the abstraction in the real world. So you have a final task. Okay, you have to shape area calculator. What does this means? You have to build an app combining polymorphism and abstraction to calculate areas of multiple shapes. Okay, you have to create the shapes by using this polymorphism as well as the abstraction. This is very simple. You have to just create a shape with class calculate area. So for round means you have to create a radius. The you have circle means you will have 3.14 into radius, right? Rectangle means you have length into width. Okay, you have to create a length and width. And then triangle means the triangle formula, base into height. That means you have to create return 0.5 into base into height. You have to notify all the data types as double. Okay, so because the value is something nearer to decimal. Okay, so this is the main. Then polymorph, the third one is a polymorphic display. This one is what means you have to create the shapes, the shape 1, shape 2, shape 3, circle, rectangle and triangle, and you have to print the values and then calculate the area of the particular shapes. This will be some easy only. Have try it yourself. Okay, if any doubt means feel free to ask in this session. Okay, so and then this is the overall concept in this polymorphism as well as abstraction. This is a very simple concept only, but once you understand this concept you will be very familiar with oops. Okay, so thank you so much for your patience. Keep practicing Java daily. Okay, also stay consistent and improve your skills. Okay, so keep learning with Life Changes Academy. Keep coding. Thank you. See you in the next video. Bye.